What if I told you that there could be an infinite number of yous, each living out a different reality in a parallel universe? This is not a plot from a sci-fi movie, but actually a deeply rooted concept in modern physics. Welcome to the enigma of existence. The idea we are exploring here is called the multiverse theory. It's a concept that our universe, the vast expanse of space and time we can observe, might just be one tiny bubble in an infinite ocean of other universes, a multiverse. Now, isn't that a mind-bending thought? Picture yourself standing on the shore of an endless ocean, each drop in that ocean representing a universe. Our universe, the one we live in, is just one drop in this infinite ocean. That's the scale we are talking about when we discuss the multiverse. It's a concept that stretches our understanding of reality to its very limits. But why should we consider such a possibility? Well, it's because our current understanding of physics and cosmology suggests that it might be true. Theories in quantum mechanics, the study of the very tiny, and cosmology, the study of the very large, both point towards the possibility of a multiverse. But what does this mean for us? If there are infinite universes, are there infinite versions of you and me? Are there universes where the laws of physics are completely different? Could there be a universe where time runs backwards? These are the mind-boggling questions that the multiverse theory raises. So, you might be wondering, what's the point of it all? Well, exploring the concept of the multiverse pushes the boundaries of our understanding. It forces us to question our place in the grand scheme of things, and it opens up new avenues for scientific discovery. The multiverse theory challenges us. It makes us question our understanding of reality. It forces us to look beyond what we can see and measure. It's a journey into the unknown, an exploration of the ultimate frontier. So, the next question is, how can we even begin to comprehend this concept? Let's dive into the world of the multiverse. The term multiverse may sound like something straight out of a science fiction novel, but it's a concept taken very seriously by many physicists. At its core, the multiverse theory proposes that there isn't just one universe, but an infinite number of universes. This is a concept that is as mind-boggling as it is fascinating. Imagine for a moment that every decision you make, every chance event that happens, creates a new parallel universe. In this one, you're listening to this video, but in another, you might be climbing Mount Everest or sailing across the Atlantic. Each possible outcome of each event defines or exists in its own world or universe. This is the essence of the multiverse concept. There are different theories about the multiverse, each with its unique interpretation. The quantum multiverse theory, for example, is based on the principles of quantum mechanics. It suggests that every time a quantum event happens, the universe splits into different universes for each possible outcome. Then there's the inflationary multiverse theory. This stems from the idea that our universe is just one bubble in an infinite cosmic champagne. Each bubble is a separate universe with its own laws of physics. The string theory multiverse, on the other hand, proposes that different universes exist in different dimensions. According to this theory, our universe is just one of many, floating like a bubble in a higher dimensional space. And finally, the ultimate multiverse theory, the mathematical universe hypothesis, suggests that every mathematical structure is a separate universe. If this theory is correct, then the multiverse contains every possible and imaginable universe. But how can we find evidence of other universes? Let's explore the scientific theories. The multiverse isn't just a wild idea. There are scientific theories that suggest its existence. As we delve deeper into this subject, we come across two prominent theories that hint at the possible existence of the multiverse: quantum mechanics and string theory. Quantum mechanics is a fundamental theory in physics that describes the physical properties at the nanoscopic scales. The concept of many worlds interpretation within quantum mechanics suggests that all possible alternate histories and futures are real, each representing an actual world or universe. In essence, it implies that all possible outcomes of a quantum event exist in their own separate universes. Just imagine, somewhere in a parallel universe, you could be sipping tea on the moon. On the other hand, we have string theory. This theory replaces the point-like particles in particle physics with one-dimensional strings. It's in this theory that the idea of a multiverse seems to naturally occur. According to string theory, multiple universes could exist on membranes in higher dimensional space, each having different laws of physics. Just think about it. An entirely new universe could exist, where the laws of physics as we know them are entirely different. Now, you might be thinking, this all sounds fascinating, but is there any evidence? That's where things get tricky. Currently, we're still searching for concrete proof. Scientists are looking for signs of cosmic inflation, which is a theory that the universe expanded rapidly after the Big Bang. This could create a multiverse by producing endless pockets of space-time, each developing into a separate universe. Researchers are also exploring the cosmic microwave background, the afterglow of the Big Bang, in hopes of finding patterns that could indicate the existence of other universes. While the idea of the multiverse is fascinating, it also has its critics. Let's hear what they have to say. As we continue our journey into the realms of the multiverse, we'll explore the controversies and criticisms surrounding this intriguing concept. Stay tuned. Like any groundbreaking concept, the multiverse has its share of skeptics. Delving into the criticisms of the multiverse theory, we find some scientists who argue that the idea is nothing more than a philosophical musing, not a scientifically testable hypothesis. They point out that if other universes are by definition unreachable and unobservable, then they cannot be studied or proven, which goes against the very principle of empirical science. One of the primary criticisms revolves around the concept of falsifiability. Falsifiability is a cornerstone of the scientific method, stating that for a theory to be considered scientific, it must be able to be proven false. However, the multiverse theory by its very nature defies this principle. It's almost impossible to conceive of an experiment that could definitively prove the non-existence of other universes. This has led some critics to label the multiverse theory as unscientific. Another area of controversy is the application of Occam's razor. This principle suggests that the simplest explanation is usually the correct one. Detractors argue that invoking an infinite number of unseen universes to explain our own is hardly the simplest solution. The multiverse theory has also been criticized for its reliance on other contentious theories, such as string theory and cosmic inflation. While these theories are respected within the scientific community, they are still subject to debate and revision. Some critics argue that building the multiverse theory on these uncertain foundations is a risky proposition. Lastly, there is a philosophical objection. Some critics argue that the multiverse theory, with its infinite possibilities, undermines the uniqueness and significance of our own universe and existence. Despite these criticisms, the multiverse theory continues to fascinate and divide the scientific community. It has ignited debates about the nature of science itself and the limits of our knowledge. Whether you're a believer or a skeptic, there's no denying that the multiverse is a mind-bending concept. So where does this leave us? So, does the multiverse really exist, or is it just a figment of our imagination? Let's dive into the ongoing debate about the existence of the multiverse. On one hand, we have scientists who firmly believe in the existence of parallel universes. They argue that the multiverse is a natural consequence of physical laws. They hold that just as there are numerous galaxies within our universe, there could be an infinite number of these universes within the multiverse. On the other hand, skeptics argue that the multiverse theory is more of a philosophical concept than a scientific one. They contend that since we can't directly observe or measure other universes, the multiverse remains an unproven and speculative idea. They caution us against accepting the multiverse theory until there's empirical evidence to support it. In the middle of this debate, we find ourselves grappling with the question, what would the existence of the multiverse mean for our understanding of reality? Well, it would certainly change our perception of the universe and our place within it. We would no longer be living in a universe, but a multiverse, with potentially infinite versions of ourselves living different lives in different universes. Moreover, the existence of the multiverse could also have implications for our understanding of physics. It could provide a solution to some of the mysteries that have puzzled physicists for decades, such as the nature of dark matter and dark energy, or the fine-tuning of the physical constants. So, where does this leave us? The multiverse theory is a tantalizing idea that has captured our imagination, but it remains just that, an idea. Until we have concrete evidence, the multiverse will continue to be a subject of debate among scientists and philosophers alike. Whether you believe in the multiverse or not, it's a concept that challenges us to expand our understanding of the universe and question the nature of reality itself.